Right. In this video, I'm going to talk a little bit about the mathematical mindset, like the things that you could try to do when you're trying to do math and you're trying to learn math that might make it a little bit easier for you to learn mathematics. All right. So I've been teaching math for about a decade now, give or take, and I'm really good at math, but I can't even count the number of times I've had students come up to me and say things like, I'm just not a math person, or, I've never been good at math, or my brain just doesn't work this way. All those things are not true, right? Those are just blatantly not true. When I hear somebody say that to me, what I think of is that this person is just making excuses so that they don't have to try to do something that they're not comfortable doing. That's basically the way it seems. When people say those types of things like, oh, I just can't do it, like you're giving up before you even try. If you try, you might find that you actually can do it. Here's the thing about math and really any subject that you're trying to learn. As you grow and develop, your brain also grows and develop, with age. So, maybe when you first tried to learn how to, add and subtract and multiply and divide fractions, like back in 4th or 5th grade or middle school, or it's been a long time since I learned how to do fractions. I forget exactly when that happens in your schooling. But whenever that was that you first tried to learn that, maybe it was really difficult for you because, well, maybe at that time your brain wasn't developed enough to really understand the concepts of what you were doing. But, maybe that's been, 4, 5, 10, 15 years since you tried that. If you go back now and try to learn how to do fractions, you might find that it's actually not that hard to do because your brain has developed and now you're able to handle those concepts, and you might look back and it's like, well, why was this so hard for me back then? Well, it's because you're more mature now and your brain is developed and you're able to get those concepts, right? So what I'm trying to say is anybody can learn math. If I didn't believe that, I wouldn't be a math teacher. Like if I thought, oh, this person's not a math person, there's nothing I can do that's going to help them learn how to do this, that would be just a horrible thing to do with my life, and I wouldn't teach math, right? So I truly believe that anybody can learn this stuff if they kind of get their mind trained to start working a certain way and do certain things to kind of help it along, right? And that's the kind of things I have up here. All right, so persistence and creativity. Right, persistence is really important in mathematics. Wanting to figure out the solution, wanting to see how it works, wanting to understand what's going on, not just like, oh, I tried this problem, I looked at it, and it was really hard. I couldn't figure out how to start, so I just gave up. And when I went and did something else. Right, that's not persistence. Right, so just working at it, having that little bit of tenacity to just keep working and trying to figure out and just not giving up. Right. Also, creativity, a lot of people are surprised at that, but creativity is something that's actually important when you're doing math, right? When you're solving a problem that you've never solved before, well, you have to be a little bit creative when you do that. You have to, think of different methods maybe that you haven't used before, or combine different things that you've learned but put them together in a new way that you have never done before in order to solve this new problem that you haven't seen, right? So creativity it is an important part of mathematics when you're solving these new problems. Right, so persistence, to not give up, and then to also be a little bit creative. If you kind of get stuck, but like you really want to figure it out, you're being persistent, you have to turn on your creative brain a little bit and say, well, what can I do here? What different methods that I've learned, maybe apply to this problem that I didn't think they would apply to. Right, so those are important things to do when you're trying to solve mathematical problems. Understanding that mistakes are common, even good, right? Mistakes are good when you're learning anything. Something I always tell my students, think about when you first learned to walk. You probably don't remember, like you were only like 1.5 years old, whatever it was when you first learned how to walk. But when you first learned to walk, you didn't just stand up and just run across the floor. Like you stood up and then you fell down. And then you stood up and you took like a step maybe, and then wobbled a little bit, and then you fell down, right? But you were persistent, you kept trying, and I mean, look at you now. You can walk around, you hardly ever fall down at all, right? Same thing with math. When you're learning math, you're going to make mistakes. It's going to happen. I'm really good at math. When I was learning it, I made mistakes all the time. It's just the nature of learning something. Mistakes are good as long as you learn from those mistakes. You're like, oh, I tried to do this, but that's not allowed in this type of problem, or that's against the rules of math to do that type of thing. Okay, so I know that now. Let me not make that mistake again, right? Next time I see a similar situation, I'm going to do something different so I don't make that same mistake, right? Mistakes are okay, especially when you're you're first learning math, like in the classroom, and your teacher says, "Oh, try this problem." Don't feel like you have to get it 100% correct every time. You're going to make mistakes. Right? When you do homework problems, you're going to make mistakes on the homework. Right? The point is, when you make those mistakes, don't just look at it and say, "Oh, I screwed this up," whatever, crumple it up and throw the paper in the garbage. Look at it. What did I do wrong? What should I have done here to do this better or to do it the correct way? And if you learn from those mistakes, you're a lot less likely to make them in the future. And then by the time you sit down to take your math test, you've already made all the mistakes. Now you know how to do it the right way, and you're going to be okay. All right, so doing those mistakes, knowing that mistakes are good, another important thing when you're learning math. And a lot of these things don't just apply to math; they apply to learning any type of thing. Paying attention to details, accuracy. I just did a video where I talked about the language of mathematics and like paying attention to where symbols are or what symbols are there or not there and how the symbols are arranged in relation to each other. Paying attention to those little details, super important when you're learning mathematics, especially as you get to higher and higher levels of mathematics. Algebra, trigonometry, pre-calculus, calculus. The more complicated it gets, the more important it is that you're paying attention to those little details, right? So it's just a matter of making yourself focus, right? Like, I need to pay attention to this. I need to focus on what I'm doing. I'm not trying to do a math problem here and texting somebody over here while I'm doing the problem. You're probably going to miss something. You're going to miss one of those little details and end up getting something wrong, right? Also, accuracy, right? Especially with like the simple things like, your multiplication tables. Like, if you don't know that 6 times 7 is 42, if you see 6 times 7, you write down 45 instead. That's an accuracy problem, right? And it's also paying attention to the details, right? So, doing those little things correctly. Mathematics builds on itself. So the first things you learned in kindergarten, first grade, how to count, how to add, 2 plus 3, all mathematics builds on top of those very simple things, right? So, when you get into doing algebra and pre-calculus and calculus, if you see 2 plus 5 and you write down 6, like, that's 7. Like, that 2 plus 5 equals 7. You just need to pay attention. You need to take your time, make sure you're being accurate on those simple things that you learned in the past so that these more complicated things that are built on top of it, you are also able to do correctly. All right, so it's another important thing there. Noticing patterns and structure. Also important, especially as you get to higher levels of math. I've never seen a problem like this before, but it looks a little bit like this other one that I learned about, last week or a couple months ago. So let me see if I can do a similar type of thing to this problem as what I did on that other problem, right? Noticing the structure that's there or noticing the patterns. Like, oh, these are like the same numbers. It's a 1, then a 3, then a 5. Those are the same numbers I saw before on this other problem. Maybe I can do a similar type of thing, right? So that's noticing the patterns and the structure, being a little bit creative, trying to pull back other things that you learned and apply them to new situations. Again, all important things. Seeing and making connections between different parts of mathematics, right? Math is not just memorizing a bunch of facts and formulas and procedures to solve problems. Some people get through math doing those types of things, but it's way better to see the connections, make connections between, oh, I learned this in algebra, but this is really similar to what I learned, how to add two fractions together. Now I'm adding these two algebraic expressions that are in fractions. Guess what? The rules are exactly the same. It's just a little more complicated now because instead of 1/2 plus 1/3, I have x plus 2 over x minus 7 plus some other fraction with x's in it. But I see the connection to just adding fractions, so I can go ahead and do this now with this more complicated type of thing. Right, so seeing those connections, all math, like I just said a minute ago, is built on top of those real basic things that you learned way back when. Right, so if you as you're learning new things, if you kind of think back to what you learned previously and see how it's connected to what you learned before, that builds that base of understanding in your mind. And it's not just memorizing, oh, this is a new definition, I need to memorize this, or here's a new type of problem, I need to memorize these 5 steps in order to solve this type of problem whenever I see it. If you understand how it's connected to what you learned before, you just apply those things that you learned previously and just extend it a little bit, and then you've learned the brand new stuff. And then you take that and extend that a little bit more, and then you learn the next things that you have to learn. That's kind of how mathematics is structured and how it works. But if you don't see the connections, it doesn't work that way for you. For you, it's just a bunch of, oh, yesterday we talked about quadratic equations, and today we're talking about polynomial equations. It's like two completely different things. It's not. They're very closely related to each other if you see the connections between them. All right. And then the last thing on here, logical reasoning. Just being methodical, thinking your way through a problem, thinking, am I allowed to do this? Before I just start writing stuff down, like, is that going to be, if I do that, is that going to give me what I need? Is that going to take me in the right direction? Is that allowed, based on the rules of math? Am I allowed to divide both sides of this equation by 0? Well, no, you can't do that, so don't ever do that thing. Right, but having those logical reasoning skills, it's not just always getting quick answers, right? A lot of the pleasure of doing mathematics, like people ask all the time, like, well, why do you like math, right? And they always have like this attitude they have when they say it, like they like, why do you like math? And then under the breath, like, you weirdo. But a lot of the pleasure of doing math comes from thinking your way through a problem and using those reasoning skills. The process of finding that solution, being persistent and being creative in finding a way to solve a problem. The people who are able to do those things enjoy doing math, right? It's almost like, if you think about it as like solving a puzzle or like playing a game of some type. You're trying to put the pieces together to make a picture, to get an overall idea of what's going on. Solving mathematical problems are a lot like that. It's the process of finding the solution, not just the solution itself, right? You solve a mathematical problem and it takes up, the entire board of work to do it, and you get down to the bottom and x equals 1. Like, all right, I don't really care that x equals 1. That's not the point of knowing what the answer was. The point was doing all that work and being able to logically think my way through the problem, and see the connections to other things that I did and pay attention to the details and see the patterns and the structure of what I'm doing to allow me to get to that solution. The solution itself is not the point. It's that whole thought process that you go through. And if you have these mathematical mindsets, these different things you can do, you might start to see, oh, I solved this problem. That was actually kind of cool. I like that. Let me go do another one. I know a lot of you are probably laughing when you hear me say that, but it's true. You'll start to see some of the pleasure of doing mathematics if you do those types of things. All right. So again, some of the mathematical mindsets, some things that you can try to do as you're doing math problems to help you out. Be persistent. Try to be creative. Understand that it's okay to make mistakes. Don't be afraid to make mistakes. There's plenty of times when I've been solving a problem and I'll start doing something. I'm like, I'm not sure how to do this. So let me be creative. Let me try this. And then it's a dead end and it doesn't work. I made a mistake. All right. Let me erase that stuff and let me try something else. Right. Mistakes are okay as long as you learn from those mistakes. Paying attention to the details, being accurate, not just trying to rush through and get to the answer real quick, but making sure you do each part of the problem properly and correctly. Especially the easier things that you learned previously. You're like, oh, 7 times 6, I know what that is. I do that all the time. 45. No, 42. Take your time, be accurate, do it right. Seeing the patterns and the structure, looking at those details. Like let me look at this problem. Not me just see the problem and start writing things down, but let me look at this and kind of analyze it a little bit and see what it looks like and see how it's related to other things I've done before and make those connections to those other things. Let me logically think my way through this. If you're able to train your brain to do those things, even just a little bit as you start working on math, you'll see that it starts to feed itself. And you just do it more and more and more. And the next thing you know, you love going to math class and you love doing your math homework and you're actually good at it. All right. So those are some things that hopefully help as you're studying math, help you do a better job at it.